welcome to the Astro. In this Python 4 astronomy tutorial, you are going to learn that how to read and visualize FITS image file from Hubble Space Telescope, which is in a space, and it works in your optical and UV regime. So first, we will be downloading our HST data from this website, and our target is that spiral galaxy is NGC 4414. Okay, so here's the image of the Hubble telescope in the space orbiting the Earth. And so first step is to download data from this website. So click on that, and then go to that website. Go here for the search, and we have to download data for this galaxy NGC 4414. Okay, so I will run the query. So here you can see that your object has been resolved. Okay, so this is a galaxy, a spiral galaxy. So let's go for the data. So see, here are the telescope which have observed this galaxy. So I will download data for HST optical. So click on that. So here you can see that a window has popped up, and I will go for your instrument wild WPF C2 in that filter AF555W filter, and I will download the data. Okay, so click on that. You can see here that my data is downloading. Okay, now I will go to my directory. I will extract, and then I will put this data to my directory in the document. Now it's fine. Okay, so we have done. Now we'll be reading and visualizing this FITS file we have downloaded recently. So let's do it. Okay, so here you can see that in my directory there is a FITS file. Okay, so I can check my directory. Now okay, so go for document, go for your HST, and okay, so here is my data. I'll copy it and put in the HST. So now its data is out here. You can check it. And now we have to read this file. Okay. So now. Okay, so for reading, we'll be importing some libraries. So here, okay, so I will import some libraries. So import library. So I will read this file using Astropy. Okay. So import Astropy. So from Astropy dot input output import FITS. Okay, so this deals with FITS file. deals with feeds file, either data table or image. Now I will read this file. Okay, so for type I here HST equal to feeds dot open, and I will give my file name. Okay, so here you can see that I will have HST. So this is my file name, hst5397.feeds. Okay, now we have read the file. Okay, so if you put HST, so it will give some information this type, but okay. So now get information about feeds file, right? So for that type here hst dot info and function and run it. Okay, so here you can see that you have this file name dot extension, and we have primary. So they are like 0, 1, 2, 3 are SDU. Okay, it's a primary SDU, science SDU, and these are other stuff. So you can see that the science SDU contains your image SDU, and it has size of 800 into 800 pixels, and data type is float 32. Okay, so this is our image, and we have to plot this image. Okay, now what I will do, I will read. Maybe you can go here. Read data from HST. Okay, so for that type here data equal to, or maybe you can type here, yeah, simply data equal to, or type image. Okay, image equal to, your data is in your first science SDU, I mean 1. So for that type here HST 1 dot data, right? So basically this gives your data. Image, there should be a small. Okay, so here you can see that it's a data and it's a float 32, and you can also check its shape in p dot shape. So if we check it, okay, so here you need to import your numpy library. So import numpy as np. So here you can check the shape of your image SDU. Now what to do? Now you can get header information. Okay, so basically your header contains information about the observations, object photometry, and other details related to the observations telescope. So for that type here phi, or here HST 1 dot header, right? Header, and run it. Okay, so here you can see that there is a lot of information about the this feeds file. You can see that extension of the image is the image extension. It's a 32 array type. It has 2 axes, and we have like XY pixel have size 800 into 800, and you can see the right ascension and declination of the object, and you can see these are like coordinate which is used to transform from pixel to your WCS. You can also check other information. You can see the photo mode, this is filter, and the camera, and you can check the zero point of the band. This is the RMS band of the filter. Yeah, you can check. It's a science. It is a name. You can the root. It's a observe, and then you can. Yeah, so you can see here the unit of the image is count per second. So basically the intensity is in counts per second, right? Okay, so this much you have done. Now we'll be reading the image file. Okay, now plot image data, right? So for doing that, I will add here from matplotlib.pyplot as plt, right? What is the mistake? Import matplotlib.pyplot as plt. Now it's fine. Now I will read the image data, okay, and plot it. Okay, so for we have here image data. Image data is image variable. Now plot it. So type here plt.image. Okay, so for showing 2D image, you have to type plt.image, not plt.plot or a scatter, and pass here image, right? You can also type here plt.figure and show it. So here you can see that almost nothing is visible. Okay, now so okay, so you can see that like where your flux is, I mean distributed. So better I will plot here a histogram. Okay, so type here plt.hist and okay, so the image is in like 2D. Okay, so we have to convert into 1D. So np.ravel image and okay, so here you can see that your whole pixels have data in this range. Okay, it is going from maximum to something like that. Okay, or maybe you can put it to the log, or maybe leave it that. So basically it means that your all pixels are contained within a very small bin. Okay, in this range. Now we'll be plotting image data. So I will now plot. So here I can see that plot pixel intensity distribution. Okay, this is your you can type here plt.x level. So you can say here pixel intensity and plt.y level, you can say it count. Now we have done. Now plot. Now plot the image data. So for the type here plt.image show and give here image and plot it. Now you can see that nothing is visible on this scale. So we'll use a log scale to show this image. Okay, so for that import a library from matplotlib dot colors import loggram. Okay, so basically this will use to like plot your intensity on the log scale. So for that, type here norm equal to log norm and now. Okay, here you can see the image of this galaxy. Okay, NGC 4414, right? Now we have done this plotting. Okay, you can also make the color bar of that. So you can type here plt dot color bar. So here is a color bar, log color bar of this galaxy image. So basically you can see that blue one has very less value of luminosity, and green from green to yellow it is increasing. Okay, so at the center it has the highest flux density, right? Now you can also one thing you can see here, that at the origin there is 0 and 700. Okay, means your origin is not coinciding at the left lower. So for that, type here origin equal to lower, and this will like put origin at 0 0. Okay, unlike earlier. You can also change the color map of this image. You can make it say jet, right? So image will look like this. You can make it to rainbow, right? You can make it to grayscale. This is the black and white image. Okay, you can also make to some summer color map. You can make it to winter. Okay, so I will put it as jet for time being. This is how the galaxy looks like, okay, in the pixel space. So here I can give a title, say plt dot x level, and I can give say x pixel, and similarly plt dot y level I can give y pixel, right? So you have uploaded this image in your xy pixel space, right? You can see the, maybe you can make it gray for black and white. Okay, so here's a galaxy image. It's like much easier to observe in the background, right? Now we have done two things, histogram and pixel space plotting. Now we'll plot image in WCS coordinate system, right? So let's plot it. All right, so let's plot it in the WCS coordinate system. Okay, so you can see that you have here like x and y pixel coordinate system. So we need to convert this xy pixel into your WCS system. So basically, like we'll extract from the header this information and we'll plot it. So for that we'll use a library. So from Astropy dot WCS import world coordinate system, right? And then my WCS can be extracted from WCS, and then HST1 and from the header, right? So if you see what this WCS is, so here you can see that these are the some coordinate transformation matrix. Okay, you can see that this is array deck of the object. This is like pixel size for x and y. This is like a transformation matrix. Okay, this matrix, so it will use to transform this into WCS. Okay, now I will put the figure. So plt dot figure, and okay, and then I will type here plt dot subplot, and then I will make my projection as a WCS, projection as WCS, and you can see a figure has been created with your array and deck. Now I will plot it. So plt dot image show, plt dot image show. I will type here image, and you can extract everything from here. No need to write again and again. And run it. So here you can see that the same image is in a different coordinate system, right? So basically you can see that this is your array and this is your deck, right? So you can make it your xy axis level. You can make it your say array and deck. Okay, this way you can do. You can also do one more thing. If you add here percentage matplotlib notebook, then you can also get a better zoom. Okay, so here you got some buttons, and you can zoom the image. Okay, see, you can zoom the image, and you can see this is the pixel value here, and this is array deck along with the object. Okay, so I expect that you have learned some new things in the Python for astronomy plotting, and you have learned that how to download data from the website, and how to download it, and then how to read the feeds file using Astropy, and how to get the feeds file information where the image is present, then how to read the image data, and how to get data information from the file, and then you have plotted the histogram for the intensity distribution of the pixels, and you have seen that pixels are in like very small range. Then you have plotted your original data in pixel space, and then you have plotted the same image in your word coded system. Okay, so this is your image in WCS system. So, thank you.